In this module, we'll unpack how a qualified electronic signature is created in an online banking journey. You'll see how remote signing services, strong user authentication, and certificate management work together to produce a legally reliable digital signature. You've already built the foundations: digital identity, eIDAS, and the bank's onboarding use case. You've seen how identity proofing and eID plug in. Now we zoom into the core of the system: how a qualified signature is created, orchestrated, and proven. When we talk about electronic signing, a key question is, where does the private key live? In local signing, the key is literally in your pocket, on a card or token, and your own device runs the crypto. That gives direct control, but creates hardware, driver, and usability headaches at scale. With remote signing, the key stays inside a QTSP's HSM. Your phone or browser only requests a signature with your consent. This model aligns much better with eIDAS-qualified banking flows. Remote signing is widely used in online banking because it scales well and feels simple for customers. They don't need smart cards or readers and can sign from web, mobile, or with help in a call. Security keys remain in QTSP hardware, so banks get strong protection, easier compliance, and can offload complex crypto and certificate management. A qualified signing solution has four main actors working together. First, the bank's front end: the app or portal where the customer reads documents, gives consent, and starts the signing. Second, the orchestration service: the brain that gathers context, prepares documents, and talks to the QTSP. Third, the QTSP platform: the secure vault that authenticates the user and creates the qualified signature. Finally, certificate management keeps keys and certificates valid, revoked, and auditable over time. It helps to think in terms of trust boundaries. The bank owns the customer journey: how onboarding looks, which legal terms are shown, and how users and documents are routed into the signing flow. It also has to integrate correctly with QTSP APIs. The QTSP owns the qualified trust layer, secure HSM infrastructure, certificate issuance, and strong authentication with detailed evidence logs. Between them, shared agreements define identity proofing, SLAs, incident handling, and evidence formats for compliance. The signing front end is the user's window into the whole signing flow. It shows what they're agreeing to, how they consent, and why they should trust it. Strong design here means clear document summaries, unambiguous sign actions, visible security cues, and a smooth experience across web and mobile in every required language. Now focus on the orchestration service, the coordinator of every digital signature. It takes raw business intent from banking systems, enriches it with document IDs, user identifiers, policies, and risk checks, then opens a controlled signing session with the QTSP. It also tracks timeouts, status, and callbacks, and exposes a clean, bank-centric API. Because of this layer, you can swap QTSPs, evolve signature methods, add robust error handling, and strengthen security without touching core business logic. The QTSP platform is the vault of the whole solution. Private keys never leave certified HSMs, which enforce strict access control and tamper resistance. On top, policy engines apply eIDAS and ETSI rules, while APIs let banking systems request signatures, timestamps, and long-term validation in a controlled way. A qualified certificate is the bridge between "this is who I am" and "this is my cryptographic key." First, strong identity proofing produces verified attributes, plus evidence that can later be audited. The QTSP then issues a certificate that embeds those attributes and the public key under its own policies. From that moment, any signature created with the corresponding private key is attributed to that specific person until the certificate expires or is revoked. For every qualified remote signature, the crucial question is, who's really controlling the key right now? To answer that, we rely on strong multi-factor authentication, often using mobile IDs, bank IDs, or eIDs. Architecturally, either the QTSP authenticates the user directly, or the bank authenticates and sends a trusted assertion. Whichever pattern you choose, you must bind that login to this exact signing transaction, keep user friction low, and match authentication strength to the risk. The first part of a qualified signing flow is all about setting things up correctly. The bank prepares the document, defines who signs, in what order, and which signatures are required. From the user's perspective, this appears as a simple invitation to sign. They log in, review the document, and choose to sign with QES. At that point, control shifts to the QTSP, who authenticates the user, shows the transaction details, and captures explicit consent. Once the user has authenticated and given consent, the QTSP checks that everything meets its policy. Only then does the HSM apply the user's private key, certificate, and optionally a qualified timestamp to the document. The signed result goes back to the bank's orchestration layer, which updates the session and stores the contract. In parallel, both QTSP and bank log detailed evidence, which later supports audits, dispute handling, and regulatory checks. In real banking flows, orchestration acts as the conductor. It decides who signs first, who can sign in parallel, and which role each signer plays, while the QTSP issues separate certificates per person. The same orchestration thread follows customers across channels, keeping state consistent even when authentication methods differ. It also treats documents as controlled bundles, enforcing version integrity so any post-signature change triggers a new, fully traceable signing event. You've now seen how a remote QES architecture works end-to-end with clear roles, strong user journeys, and scalable cryptography. In the next module, we'll focus on proof, how each signing step generates evidence you can structure, store, and use for audits, disputes, and long-term compliance.